Hello and welcome to this Osmosis and SubQuery virtual workshop on data indexing. In this workshop, we're going to cover what is Osmosis and what is SubQuery. We'll look at the SubQuery solution overview. And then we'll jump into a quick demo brought to you by Matt from Osmosis. Great to have you here. And then we'll round off with a summary as well. First of all, what is Osmosis? Osmosis is a decentralized exchange using an advanced automated market maker protocol. You can swap, earn, and also build exciting decentralized applications. And it's also run by over 150 validators and full nodes. As the largest interchange DEX, there's just under $200 million in total value locked, with a 24-hour trading volume of around $47 million and over 1,000 interchain transfers. Now, when developers are trying to build blockchain projects, there are challenges that they are facing, and the main ones are where and how to get blockchain data. This is where SubQuery comes in as an end-to-end blockchain indexing solution. SubQuery includes an open source data indexer, where developers can build blockchain projects, and once this is done, it needs to be hosted somewhere. For example, Google Cloud, AWS, or even SubQuery's own managed service solution. The third option that SubQuery offers is a decentralized marketplace where projects can actually be given to indexers who can then run it on their infrastructure and then serve the data to consumers who can then query for the data to run or power their own applications. Now, many people ask, why SubQuery? Well, as a blockchain indexing solution, SubQuery is open source, meaning that the code is available for inspection and auditing, and bounties are awarded for any bugs found, making the code base more robust over time. SubQuery is also easy to get working. Getting up and running for the first time with a starter template project can be done within minutes using a Docker container. It's also simple. To start indexing your project, only 3 files need to be modified before index data is returned. It's highly customizable, where you can get the exact blockchain data you need when you specify your schema file. And it's also fast because you only index the data that you need. It's feature-rich, providing the ability to scaffold projects via API contracts. There's syntax discovery, historical state querying, and lots more. It's also real-time. You can access blockchain data as soon as they appear on the blockchain. It's multi-chain by design, meaning that you can get blockchain data from multiple networks all within one project and one API. As mentioned, it's flexible. You can self-host, use our managed service solution, or participate in our decentralized network as a data provider or a data consumer. And finally, it's EVM and WASM compatible. This means that you can access blockchain data across a wider range of networks, in particular the large Ethereum ecosystem. You can see the SubQuery supported networks here. At the top, we've got the EVM networks. We've got Polkadot. This is where SubQuery initially started from. And then in Cosmos here, we're actually the largest blockchain indexer in the Cosmos ecosystem as well. When creating an Osmosis starter project, we've got this template package here that anyone can use to get up and running really quickly and to continue to build upon customizing this for their own project needs. You can scan the QR code here or run the command line to download this working starter project anytime. Now, for those wanting to build a project, there are some prerequisites. Firstly, you'll need Node.js, which can be downloaded from the nodejs.org website, or if you're running Brew, you can run brew install node. Next up, you'll also need a Docker, as mentioned. download this from the website or with Brew as well. And then finally, you'll need the SubQuery CLI, which can be installed via npm install -g for global at SubQuery CLI. Once this is done, there are essentially only 3 steps required. The first one is to define the shape of the data that you want to index, and this is done with the schema file. You can then configure your endpoints and filters within the manifest file. And then you can transform your data with the mappings file. So in this particular demo here, the goal will be to index all swaps on Osmosis's on-chain DEX. There are 2 links here. One link is to the Osmosis starter project, and the other link is to the quick start guide, which you can use as a reference later on. So let's jump into the demo here, and I'll hand this over to Matt from Osmosis to take us through the actual project itself. Over to you, Matt.
All right, thanks, Sean. So for the demonstration, I'll be going over the tutorial SubQuery provided us, to walk over a few steps on how SubQuery does indexing or how to add new messages you want to index, and actually try out testing indexing the new message that we've added and check on MinScan if this is an actually existing valid transaction. All right, so the first thing you need to do here when you open your project is make sure to hide the start block you're using is a valid start block. You need to go to rpc.osmosis.zone.status and then check the latest block height, which is right here, 12.82365. Just confirm that the start block is somewhere around the latest block heights, and make sure that the node has the necessary information, the necessary blocks to process our transactions. Now, if you've done that, we're ready to actually start organizing and parsing transactions. The first thing you want to do is go to schema.graphql. This is where we add new types. We want to be parsing to the existing schema.graphql file. It's also fine if it doesn't exactly match the structure or the fields defined in the proto from the original project. This is just defining how we're going to parse it. See here, we can see that this swap field type has swap out, swap in combined together, and we've defined 3 different messages for swaps and joins. Once you've added your schema to schema.graphql, just make sure you run yarn code gen to get the types generated needed. Right. Once you've generated your types, the next thing you want to do is go to project manifest file, which is going back to project.ts where we edited the start block, and we want to declare the chain types here. These point to protobuf files that defines the format of the message to help the SubQuery project understand how to parse the data. And here we can see if we do a little search on chain types, here we can see that we've already added these messages from this specific profile. You can see that in the home directory we have tx.proto already, and this signature matches the message that we want to parse. Once you've added the chain types, we want to go to data handlers, and this is where the handler will be triggered when the filter criteria are met. Basically, whenever subquery sees one of these messages, we're telling it what to run, what method to run. So here we're telling it to run this specific handler when we encounter this swap messages. Okay, now that we've defined handlers, we've pointed it to a handler. Now we need to actually go define a handler, which is done in mapping handlers.ts. Here we can see we've separately defined handlers for swap in and swap out, which basically we're parsing what was in the message into a format that subquery can actually get a good query out of, and save it in a format that we can query out of. Yeah, so that's basically it for defining. That's basically the steps that you want to take when you're defining or when you're adding a new transaction. Once you've done that, basically the 3 steps, you want to run this magic command yarn dev, which basically runs everything, code gens everything, runs the Docker containers so that you can start, querying. So on the left side is I already had it running for a while, and we'll be testing it out if this is parsing well. Okay, by default, this is the UI you would be seeing if you go to localhost 3000 port. So I'm just going to paste in the query that I want to do. You can also find an example query that you can do in README. You can also take a look at the schema that's already defined to help you, know which ones to query. For now, I'm going to be querying for token out denoms, which has the token out swap token outs, which has the token out denom, token out amount, token in max fields. And then I'm going to just hit the execute button here, and now we'll see that the different transactions being parsed in accordance to our filter and our query. Okay, now what we're going to do is actually see if we're parsing a valid transaction. The ID we see here is the transaction ID. I'm just gonna go ahead and copy and paste, and we do see a transaction. Swap exact amount out. That was exactly what we were looking for. It was sent by Osmo 1F2. Let's go. Yep, the sender is 1F2. Send about like 4 and 5.2. Let's see if this matches. Yep, 520 USDC and 40 TIA. So that matches up well. So now we can see that we have a perfect result. Yeah, that's basically the end of demo today. Back to you, Sean.
Thank you very much for that, Matt. That was very interesting. Let's now look at the summary, where we took a look at what Osmosis is. We looked at what SubQuery is. And then we covered the 3 simple steps to create a project. And then finally, we index all swaps on Osmosis's on-chain decentralized exchange. The decentralization and tokenization of the SubQuery network is actually the next big leap for SubQuery. This completely decentralizes your application stack and also incentivizes your community to run the infrastructure for you. SubQuery's Kepler network is live at the moment. You can scan the QR code here to take a look at the network as well. If you need more information, feel free to jump over to SubQuery's technical documentation at academy.subquery.network. And for Osmosis, you can find this at docs.subquery.network. shop.osmosis.zone. For further information, feel free to visit the links on screen here or join our active Discord community. Here are some links for Osmosis, the website here, and also the link to the active Discord community as well. Hope you found the workshop useful and have a great rest of your day.